Rivets hold a lot of things together. Products fabricated with rivets include aircraft, cars, computers, and household appliances. Installed with a rivet tool, these fasteners create strong and permanent joints. Without rivets, a lot of things might fall apart. Whether the job is large or small, chances are there's a rivet for it. And using a special rivet tool, it's possible to form strong attachments quickly and easily. Just take aim and pull the trigger. The rivet tool starts with a precast aluminum handle. A technician inserts a steel sleeve. It will serve as a chamber for hydraulic fluid. The spring for the tool's trigger is next. She screws an aluminum plate to the base to enclose the two parts in the handle. This is the pulling head assembly. It has tiny jaws to grab the rivet stem. She lubricates it and presses it into the main bore of the rivet tool. She installs a fill screw in the top of the handle casting for top-offs of hydraulic fluid during servicing. But the initial supply of hydraulic fluid is added through the steel sleeve at the bottom. She inserts an air piston assembly into the fluid-filled chamber. She threads a screw into the nose of the rivet tool. This keeps the internal workings in the correct position for the next step. She places the base of the tool into an air chamber. She hooks up an air hose and secures it with steel clamps. She plugs the tool into an air supply and pulls the trigger. The air puts pressure on the hydraulic fluid inside to activate the riveting mechanism. And now, the test. She places a rivet in the nose of the tool. She inserts the other end of the rivet into a hole on a test plate and presses the trigger. The tool efficiently installs the rivet in the hole. It's time to stock up on rivets. They make them from round wire. A machine cuts the wire to length and then punches it into a die twice to form a rivet stem blank. Here's the cutting and forming action in slow motion. The machine operates in a blur, producing 200 rivet stem blanks a minute. The stem blanks move between serrated rolling dies. The dies form grooves to allow the stem to be gripped by a rivet tool. They also make ridges that will serve as a breaking point during rivet installation. This is a slow motion close-up of the serrated rolling dies in action. Here's the rivet stem before and after forming. The next machine creates the rivet body. It cuts wire to the correct length and forces it into dies. It takes 5 punches to transform the solid wire into a hollow rivet body. These machines can produce up to 300 parts a minute. Next, the rivet bodies go for a tumble in a cleaning solution to remove oily residue left by the forming. The rivet stems also undergo this thorough washing. The rivet bodies then travel through a furnace. The intense heat, followed by a gradual cooling, anneals the metal to free it from internal stresses. After zinc plating, the rivet bodies head towards the next station. The rivet stems are also on the move. They travel through a channel that gradually widens to sort out stems that are too big or small. The undersized stems fall through at the beginning, and oversized ones fall off the end. A magnet loader collects the correctly sized stems, and the rejects are discarded. The rivet stems cling to the loader, which has been stopped for our camera. The rivet bodies now ride a carousel. It pauses briefly to allow a stem to be inserted into a body. These are slow motion shots. Let's bring the action back to real time. These machines work fast. They pump out millions of rivets a day. The rivets are now ready to leave this factory for another one, where they could be used to make almost anything.